Now we are going to start with a new topic of surface chemistry, that is the colloids, right. So before we start up with the colloids, I want that you should know that in which category the colloids actually fall. So what do we have? See, we have mixtures, right. So what do you mean by mixtures? Mixtures are those which are formed when two or more components are simply mixed, not chemically combined, right. So likewise we can write when two or more substances are simply mixed but not chemically combined. So they form actually mixtures. Now we categorize the mixtures into two types depending upon the properties. One is the homogeneous, other is the heterogeneous. Homogeneous is that which has uniform composition throughout. Uniform composition throughout. Like you can see the orange juice. So from wherever you pick the sample, it is going to possess the same properties. Heterogeneous is that which has non-uniform composition. Which has non-uniform composition. Likewise, suppose we have a mixture of haldiram. You all relish actually eating the haldiram mixtures. What do you get? Like if you choose a certain sample, you get a cashew or a peanut in 3 or 4 pieces. And when you take a sample from some other side, you won't get. It is a probability that you don't get a cashew or a peanut. So that means it is a heterogeneous mixture. It is possessing a non-uniform composition, right. So we classify the homogeneous mixture into 3 categories depending upon the particle size. Depending upon the particle size, we categorize into 3 categories. One is the suspension, other is the colloid, and other is the true solution. So let's look up for their the diameters. So in suspension, the diameter of the particle is more than 1000 nanometer. That means it is quite big in size. It is quite big in size, the particle size. And when we talk about true solution, then the diameter of a particle less than 1 nanometer. So that means it is too small. Right. And when we see for colloids, they actually lie between the suspension and the true solution. The diameter being between 1 nanometer to 1000 nanometer. So that means their size is between the big suspension and the small true solution. Let's see that the size is something, this thing, lie in mid of the this thing. Now we are I'm just going to illustrate you with an example of certain properties related to them. Suppose I have a beaker, water in it, and I am adding mud to it. What I am adding? I am adding mud to it. So when I stir this mud in water, what do I get? I get a solution that I get to see that mud actually dissolve in it. But you know that it doesn't get dissolved. When we'll keep it undisturbed for certain time, it will settle down, it will separate down. So that is what is the suspension. Right, the particles, like that means the particles when left undisturbed, they just settle down. It is a property of the suspension. And you know that if I just try to pass this mud solution through a filter paper, mud won't pass. The water may pass, but the mud won't pass. It will just stick to the filter paper. So this is what we mean, that because the suspension particles are too big in size, so we can actually separate them. They even do not pass through sieves also with the finer pores. They get stick to the pores. So this is what is the suspension. Now when we talk about the true solution, so you know that the particle size is too small. So let's take an example. Suppose I have water. In water I have, let's say, ink, or salt also you can take. Right. So what I get to see actually